So, ladies and gentlemen, everybody out there, it's Philip 20, and I've been under project here. You can see that I picked up a battery on credit from PayPal, from eBay, and this is one of them. So we got two more over there, and I'm gonna try to explain to you what we got here going on. We've got a 48, a 24, a 48, and another 48. We also got a 24 on the other packs over there. And let me try to explain. This is the negative terminal. You see this white strap, white tape with black tape going across. That is considered my negative terminal. Here's negative, 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 negative. So I covered it with white tape to give an idea as a neutral, etc. if needed. And then it runs through this cable into my gigantic cables, because I don't have a bus bar to attach them to, etc. I'm just trying to get by without spending any more money. Now we've got an entire battery bank. This is supposed to be 16.5 kilowatts ish, 16 kilowatts, some people say. So how I've done this is I'm running fuses off of the main power bank, which is the positives, and this is the 24 volt positive. You go to the other side there, this is 8 gauge wire going into the other side of the other 24 volt bank, so it makes it a 48 volt bank. So I will have to tie together a BMS that is controlled both of them. So it'll control these two batteries as one bank. I'll run all the power circuitry this way from that far side to attach to this, but the rest of them, they'll actually just stay on there. So how this is work, I got a 40 amp fuse, and I couldn't find thicker gauge wire. These are cheaper for me. They're $3 each. I bought 8 of them. Actually, I bought 10 of them. I bought 10 of them, and 8 of them are on this circuit. One of them I didn't use, and another one is on the circuit right on inside the inverter box that controls the emergency shutdown for the battery bank. So if any of these batteries get below 39 volts, my entire inverter gets disconnected and it won't possibly restart, because I have a transformer that is pulling power off of the inverter itself, and we don't have power going into the inverter. It's disconnected. So we got power that can feed the house, but the power that was going into the inverter is disconnected. So as you can see here, I've modified my MP panel. Well, not technically modified it. It's going to do exactly the same as it did before, except there's another circuit. So this wire here comes from the AUX, from the Classic. It's a 12 volt power source going to a relay that is a normally open relay. I'd like to have a normally closed relay. It would work better, but it's a normally open relay. Now it's got a 12 volt coil. Turns on and off. The coil is isolated from the circuit inside, so I can run different kinds of voltages. So from DC I can switch to AC current, and from AC as an AC current I can use this 40 VA transformer, which is maximum is probably like 30 watts ish. It's it's a little warm, but it's not hot. I'm assuming it's 110 degrees. It uses about 33 additional watts by my calculations. At 240 volts, it's doesn't even show up on the load when the magnum's off. So when the magnum's running, this light is running and this transformer is running, the contactor's pulled in, and this relay's running. It's pulling about 50 watts total for the system to be on. So I leave my light on 24/7 as a little night light inside of here. It's a plastic shroud, it's not metal. So, you know, if something happens, it's plastic. But what this transformer here and this relay here is doing is turning on this relay. And I can show you that relay in the video. You can see what it looks like. Now I've got two 6-gauge cable wires going from this circuit to that breaker, and then it goes through the relay and then out to the inverter. And by doing this with this three-phase relay, I can run the 3-phase in parallel to make it a single conductor with 3 circuits going through it. As a single conductor with 3 circuits going through it, I can run 180 amps continuous on this one here. So 180 amps continuous, that's pretty good. The transformer, I've also added a fuse link, a 5-amp fuse link, so we don't burn up the coil for whatever reason. It'll blow the fuse before it burns the coil up. Whenever it hits 39 volts, oh, the Classic's talking to us.
Battery state of charge is 6%.
Okay. So, whenever it gets below 39 volts, this is going to shut off the inverter. The Classic will still be charging the battery bank, the lithium battery bank that we got. So, you know, our safe zone with the inverters, it's pretty cool. I mean, I'm pretty happy. It'll shut down the inverter so it don't go too low of discharge. Now, the next part is you're gonna say, where's your BMS? Well, I don't have one yet. I'm looking into it, and Bobby Seller Homestead, I'll leave a link in the description below. He is the one that convinced me that lithium's probably the way to go. And look, I've got these NiCad batteries. They work pretty good, but I had to leave the garage door open with a fan, you know, circulating air through the house, and they had to go. The gas had to go. So, and what really, you know, turned the knob for my wife was I found rat droppings in my downstairs bathroom. So she was pretty disappointed about leaving the garage door open anymore. So that had to be fixed right there. And now the NiCads are currently off. I will rebuild these batteries from the ground up if nobody buys them. So, but as of today, I'm gonna drop the price down a little bit more. I'm dropping it down to $1,400. And you know, if, for instance, nobody picks these batteries up, I will rebuild them. And I've got a hold of some information in the past that I didn't really worry about doing because I was using the batteries daily, and now I don't have to use them at all. I can disassemble the whole bank, work on them all, work on all that stuff, and make it an immaculate system. So I can probably get, you know, a good 30 kilowatts out of these batteries if I rebuild them. So, you know, if nobody wants to get that, that's fine, I can do it too. But I wanted to show you the circuit. So 12 volts goes in this relay that's normally open. It stays on continuously. So for instance, I have it running as a fan on high voltage. If the voltage is above 39 volts, it's calling for a fan, which is technically this relay. It's not a fan, but that's how it's programmed. So when this relay energizes above 39 volts, then this contactor energizes if there's 240 volts going through this relay here. So if the power turns off on the inverter, the transformer won't turn back on. And then, and hence this won't turn on neither. So literally you have to press the contactor in here to turn it back on. It's a catastrophic failure prevention device. If it's going below 39 volts, well, that's got to shut off. It has to. And that's all there is to it. There's no way for me to stop it from not shutting off except for avoiding going to 39 volts, which is pretty easy to do currently. I've got 250 amp hours calculated. I'm not sure how far down it'll go, but I'm pretty sure where I'm at, I've got like 300 amp hours before it gets to that point. I've got an alarm upstairs that's gonna start alarming at 40 volts. The voltage doesn't fluctuate with these lithium batteries at all. It just steadily goes down slowly, like a lead acid battery. Now, a lot of people's gonna say, well, they always stay the same voltage until they're dead. Well, the Chevy Volt batteries are a bit different chemistry. You should go look them up. It's a difference between cobalt and something else. I'm not exactly sure, but I don't know the chemistry behind the battery. I just know how it's been working for the past day and a half, and it's working immaculately. I'm talking, I'm pulling 7 kilowatts of power out of this system a day, and recharging is kind of tough because yesterday I made 16 kilowatts of power. I ran the stove in the morning, and at night I'm running the laundry, the dishwasher, and the stove, or daytime, nighttime, doesn't really matter. I'm just wasting energy, and these batteries are taking it. Now, literally, I've just got so much extra power that if it does go below 39, it's gonna be surprising to me unless it's really cloudy. So today it's partly cloudy. I'm gonna let it run, recharge, and not use a ton of power. Right now we're at 45.7 volts, and I expect it to hit 48 volts, which is the limit. I'll be backing that down some. I want to get to a lower voltage versus a higher voltage. So the maximum is 50 volts. The comfort zone is probably 47 and a half. Right now I'm at 48, and I'm backing down every day to see how far I can go down, because shutting the inverter off is obviously going to turn the power off in the system. Remember, I told you I shut this breaker down by unwiring it and turning the breaker off over at the main panel. So we've got our wires here unwired, so we can't never overcharge these batteries to the lead acid standard 58 volts from this inverter, or whatever it is. I think it's 58, could be wrong. But since I don't have the controller, I can't control none of that stuff with the inverter. So I've got a contactor and a transformer, and I build all this stuff in the garage, and it's pretty fun. So I'm pretty happy with it, and I don't want to make this video any longer because it's already 10 plus minutes. So please like, subscribe, and share. This is my DIY Powerwall so far. We've got all those batteries through there covered up, and it's pretty cool. I like it. You can see how it's going to be wired up. So thanks for watching. This is solar power, electricity, and electronics, and I'm gonna holler at y'all later. Peace out. Hello, ladies and gentlemen. Thanks for watching all the way to the end of the video. There's lots more content coming. Click the subscribe button below. Make sure you come back for more, because there's great content always coming up every day in this channel. See you next time. Peace.